Okay, now let's talk special cases. So this is the exact problem from example 2 from a few days ago when we did it by graphing. And what we found was those two lines ran parallel and never touched. Okay, so we're gonna understand from our answer here that these two lines are gonna be parallel and never touch when we get to our answer. Okay, so I'm looking at this and either one looks okay as far as which equation I want to rearrange, because in either equation the coefficient of x is positive 1. I don't want to work with the negative 2. I don't want to have to divide everything out to get y equals positive 1. So I'm just going to rearrange and solve for x. So it's the top equation, so I'm just going to rearrange that one. Excuse me. So I'm going to get x by itself, so I'll add 2y to both sides. So x is equal to 2y minus 6. Once I now know what x is, I'm going to come down to the second equation. Since I rearranged the first, I'm going to sub this back into the second. Okay, if you rearrange and sub back into the equation you rearranged, you're going to get the same value and you're going to think it's infinitely many solutions. So you've got to rearrange one and sub it into the opposite one. So now I'm replacing this x with what we know x to equal 2y minus 6. Minus 2y is equal to 2. Okay, so I'm not ready to solve since I haven't simplified on the left-hand side. So when I do, I combine my like terms, and what happens is 2y and negative y cancel. And I'm left with something that can't possibly be true. Negative 6 can never equal 2. So we would say no solution. You guys may have used empty set in the past, but what we're showing here is that these two lines were parallel. They ran parallel, had different y-intercepts, and never crossed. It is inconsistent.